Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in 8086 microprocessor. We're going to see the instruction set of 8086. We've already started the instruction set in previous video where we have seen only a data transfer instruction, and in this video we will see what is arithmetic and bit manipulation instruction in 8086. When we say about arithmetic instruction, it's nothing but the arithmetic instruction which performs the addition, subtraction, multiplication and division, right? So the 8086 will perform this arithmetic operation. We normally know all these instructions: addition, subtraction, multiplication and division. Apart from this, there is other important instructions in 8086. Whereas you can see add is nothing but the instruction which is used to add the byte or a word, and this is the normal addition without involving the carry flag. And ADC is same instruction, that is same addition instruction involving the carry flag as well. And INC is nothing but it will increment the byte or a word, right, by 1. And similarly, these two instruction is very new, that is AAA and DAA. This is very important instruction in arithmetic instructions, right? What is AAA? AA is arithmetic adjust after addition. Adjust after addition. And DAA is decimal adjust after addition, right? So now what is AAA? Used to adjust the ASCII 2 after addition, and DAA is used to adjust the decimal after the addition or subtraction. What does it mean, right? So I'll explain that. We normally know BCD operation, right? And what is AAA? AAA will be used in unpacked BCD. It is used in unpacked BCD. And whereas DAA is used in packed BCD. Right? So what is meant by unpacked BCD and packed BCD? Unpacked BCD is nothing but, we know that normally a BCD format, right, like binary decimal, we have a BCD format as well, where like whenever the result exceeds 9, right, we will be adding 6 to it, right? So what is unpacked BCD? In unpacked BCD, you will be having only the lower nibble. That is, say for example, if you are representing 8, right? If you want to represent 8, what you will do is you will represent like this, right? 0 0 0 0 and 1 0 0 0, where this is the lower nibble and this is higher nibble, right? This is called unpacked BCD, which means the higher nibble will always be 0. That is 1 byte. The higher nibble will always be 0. Only the lower nibble will be having the value. This is called as unpacked BCD. And what is meant by packed BCD? Packed BCD is nothing but both the nibbles will be filled. Say for example, if you're going to represent 73, right? How will you represent 73? You will represent 0, 1, 1, 1, and 3 will be represented as 0, 0, 1, 1. So now the lower nibble and as well as upper nibble both are filled. This is called as packed BCD. Sir, why is that you are saying packed BCD, unpacked BCD here in AAA, right? Now, this, as I said, this AAA is applicable only to unpacked BCD and DEAA is applicable to packed BCD, which means after addition, it will adjust the result, right? That is, it will adjust the result of the accumulator, right? That is, as I said, it is unpacked BCD, so it will always work in the AL register, right? That is, the lower nibble, it will only check the lower nibble of the result, and if the lower nibble is greater than 9, if it is greater than 9, then it will convert that to the correct BCD form by adding 6 to it, right? That is AAA. I repeat that. What it will do is, after performing the addition, the result, it will check the lower nibble, and if the lower nibble is greater than 9, it will convert that to the correct BCD form by adding 6. And what is DAA? It converts the higher nibble and as well as the lower nibble to the correct BCD form. Whenever the result of the upper nibble or the lower nibble exceeds the 9, it converts the correct BCD form, right? And that is why we call it as, it can be used in packed BCD, right? And next instruction is subtraction instruction. We know what is SUB, subtraction instruction. It will subtract the byte or a word, right? It from the source and the destination, right? And as well as SBB is same subtraction involving the borrow flag. And similarly, decrement is nothing but it will decrement the word or a byte by 1. And this NPG is negate information, a negate instruction, where this instruction, what it will do is, you can see, used to negate each bit of the provided byte or a word and add 1. It's nothing but simply it does the 2's complement operation. What it will do is, whatever information that is present, right, whatever byte that is present, it will convert each and every bit to the complement form. That is, if it is 1, it will become 0, and if it is 0, it will become 1, right? Like that, it convert and it will add 1 at the last, right? So that it nothing but a 2's complement operation, right? And CMP is nothing but compare operation, where the compare instruction, where it will compare 2 bytes, right? It can be a source and a destination, or any 2 bytes that can be compared. And AAS, similar to AAA and DAS. This is ASCII adjust after subtraction, and digital adjust after, decimal adjust after subtraction, right? So it's the same operation, where it will convert to correct BCD form only for the lower nibble, and here it converts both higher nibble and lower nibble after subtraction. Whereas AAA we see after addition, whereas in subtraction, like in triple AAS, it is after subtraction. This is also applicable for multiplication and as well as division, right? So you can see the instruction for multiplication. MUL is normal multiplication between unsigned byte or a word, and similarly I multiplication, that is IMUL is the instruction that is used for multiplication using signed bit multiplication. It can be a byte or a word, right? And AAM, once again, it is after multiplication, it will convert the lower nibble to the correct BCD form. Similarly, division, DIV is nothing but normal division of unsigned word, right? And IDV is nothing but normal division of signed word or a byte. And AAD is nothing but it will adjust the result, right? The lower nibble, it will be converted to the BCD form, right? The same like the other instruction, right? And similarly, we have CBW and CWD. This is very important instruction and very new instruction, right? CBW is nothing but convert bit to word, and CWD is nothing but convert word to double word. Convert word to double word. What does it mean? You can see here, CBW used to fill the upper byte of the word with the copies of sign bit of lower byte, right? What does it mean? Say for example, I'll repeat this again. Used to fill the upper byte of the word with the copies of sign bit of the lower byte, right? So what does it mean? I already said it converts bit to word. Say for example, we know that we have AX register. What is AX register? We have AH and as well as AL register, right? And when you execute this CPW, what it will do is it will extend the sign bit. Say for example, if the content in the AL, you will have some content, and if AX is 0, if there is no value, right, it will extend the signed bit of this AL, the lower byte, to the higher byte. What does it mean? Say for example, if the signed byte of AL is 1, then all these bits of AH will be 1. If it is 0, then that will be extended to AH. That means the signed bit of the lower byte, it will be extended to the higher byte, right? If it is 1, all the bits will be 1 in the higher byte. If it is 0, then all the bits will be 0, right? Similarly, you can see here, CWD used to fill the upper word of the double word with the sign bit of the lower word, right? What does it mean here? It is only upper word and lower word, but here it is upper word and double word. What does it mean? It's nothing but whenever we use register pair. For example, we use register pair DX and AX. DX and AX. Then it is called as double word. Right? So now what it will do is we will extend the upper word, sign bit of the upper word for this particular register. Say for example, if this AX, right, the signed bit, the MSB of this particular AX is 1, then all the bits in this DS register will be 1. If it is 0, then all the bits will be 0. Same like this one, but it is a register pair. That is why we call it as a double word, right? So CBW, CWD is a very important instruction in 8086. Right, and we will see about logical instruction, which cannot be also called as bit manipulation instruction. Right, what is bit manipulation instruction? It performs logical operations like logical shift, AND operation, NOT operation, OR operation, all those things. Right, we know what is NOT operation, which is nothing but the inversion. Whatever byte information given, all the byte it will be inverted. Right, and AND operation, it will perform the AND operation between the given byte or a word. And it performs the OR operation, that is, it will multiply the bytes, that is the given byte that will be multiplied, that is the OR operation. And XOR operation is nothing but it performs the exclusive OR between the given source and the destination bytes, right? And test is a very important thing where it is used to set and reset of flags, right? And what it will do is, normally what it will do is it will perform the addition of bits with the given bytes, right, with the given word. What it will do is it will do a bitwise AND operation. It will do a bitwise AND operation, but it will not store the result in the accumulator. What it will do is it will only update the flag depending upon the result. If there is carry, it will enable the carry flag. If it is 0, it will enable the 0 flag. So what it will do is for the given operand, it will do a bitwise AND operation and only update the flag. That is called as test instruction, right? So another important logical instructions are it performs shift operation, where when it comes to shift operation, there can be a logical shift or an arithmetic shift, where SHL and SAL is nothing but the SHL is logical shift and SAL is arithmetic shift, which is the same operation, where from the name itself you can understand it is used to shift the byte or a word towards left, right? And after shifting, what it will do is it will put the 0 in the LSB, right? The LSB will be put at 0. That is in this particular instruction. Similarly, for a write instruction, that is shift right, what it will do is it will shift the given byte or a word towards right and put 0 in the MSB, right? And what is SAR? SAR is shift arithmetic right. There is a small logic change between arithmetic right and as well as logical right. This is SHR is nothing but shift logical right, right? So what is SAR? It is shift arithmetic right. So it will shift the given byte or a word towards right and copy the old MSB, what is the previous MSB, to the new MSB, right? Remember this, right? So, and the other instructions are the normal rotate instruction, which we normally know. The rotate instruction, which is rotate left, rotate right, and as well as rotate right and rotate left, involving the carry flag, right? So ROL is nothing but rotate left without involving the carry flag. So all the byte or all the bits in the word will be rotated towards the left, right? It will be towards the left, and so the MSB will become the LSB and the carry flag will remain the unaffected, right? And similarly ROR, which will shift all the bytes towards right, and the LSB will become the MSB and the carry flag will remain not affected. And when it comes to RCR, it is the same right operation, rotate right, rotate right operation involving carry flag. So what will happen? It will rotate towards right and LSB will be turned to carry flag and carry flag will be turned to MSB, right? These two instructions, no carry flag is involved, but here the carry flag is involved, right? So rotate left RCL, which is nothing but involving carry flag. So it will rotate all the bits towards left and now the MSB will become the carry flag and carry flag will become the LSB, right? So what we have seen today is we have seen arithmetic instruction and logical instructions of 8086. When it comes to arithmetic instruction, all are very simple instruction which we normally know, but you got to be very you got to understand what is AAA, DAA and how it works for different arithmetic operation, right? I believe this video will be very useful for you. Thank you, my dear students.
தேங்க்யூ ஸ்டூடெண்ட்ஸ், தேங்க்யூ ஃபார் வாட்சிங். கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.